In this video, I'm going to look at transformations of periodic functions. So how to graph a function that looks like this using transformations. So we've done transformations before. So in general, you have the function y equals a f k x minus d plus c, which would be the transformed graph of y equals f at x. So this could be any type of function, a cubic function, an exponential function, absolute value function, all ones we've looked at before. And it's these parameters a, k, d, and c which cause transformations in the graph. So you talk about vertical stretches, compression, shifts, horizontal, vertical, reflections. When you do a periodic periodic function, so sine or cosine, you're going to do it slightly differently. So with a periodic function, you have four key features. You have your amplitude, and what you're going to do when you are graphing these is figure out what happens to these key features. So with our amplitude, we have to figure out which of these parameters, a, k, d, and c, is going to affect the amplitude. And the answer is the one that affects vertically, and it's the vertical stretch. So the vertical stretch is 2. So this parameter here causes a vertical stretch by a factor of 2. So a is equal to 2. So the amplitude of your normal sine function is 1. So a vertical stretch by a factor of 2 is going to create the new amplitude of 2. So whatever number this is, or the absolute value of whatever number this is, will be the amplitude. So the amplitude is 2. Okay, so that's one key feature. Second key feature we're going to look at is the equation of the axes. So the equation of the axes on your normal sine function or cosine function is y equals 0. So that's the midline, or the line that goes, the horizontal line through the middle of the graph. That's going to be affected by the vertical shift. So the vertical shift is this number here. So it shifted up 1. So we're going to have an equation of axes which is 1 greater than 0 or 1. So y equals 1 will be the equation of the axes. The period is the next one. So the period is going to be affected by a horizontal compression or stretch. So that's this number here, your k value. So the k value, a positive k value will cause a horizontal compression. So your period is going to be equal to 2 pi divided by the k value. So if it's a horizontal compression, the period will shrink. If it's a horizontal stretch, the period will compress. So in this case, the period is going to be 2 pi by 3, so 2/3 of pi will be the new period for this graph. And then the other transformation is the phase a phase shift. The period was here. Now you got to be a little bit careful with your phase shift. At least, especially the way I've written the equation. So notice when it's written like this, the x minus d is in a bracket. Here, the x minus this term here is not in a bracket. It needs to be, so you need to common factor the k value from this term here. So this is going to become y equals 2 sine 3, and I have to common factor the 3. So it would be x minus, if I divide pi by 2 by 3, I get pi by 6 plus 1. Okay, so the phase shift is going to be pi by 6 to the right. So remember, if it's minus pi by 6, it goes to the right. If it was plus pi by 6, it would go to the left. It's kind of the opposite of what you would often think. Okay, so now how do you graph it? So I'll draw my axes. So the key here is setting it up right. You want to make sure you have an appropriate scale. If you've got an appropriate scale, this is going to be much easier. So the first thing I'll put on my vertical scale. So for a vertical scale, I need to make sure I've got my maximum and minimum values. So I know I have an equation of axes of 1. So I better make sure I've got 1 on there. So 1 will go right there. My amplitude is 2, meaning I have to go 2 values above this and 2 values below this. Let me put 1 a little lower. So 1 will be here. So my amplitude's 2, so I have to be able to get up to 2 above that, which is 3, and then 2 below that would be -1. And this is my equation of the axes. A lot of times I'll suggest putting a sort of horizontal line right across that equation of axes line. Now for a vertical scale, and this one's the one that sometimes people find tricky. You have to think about what a normal sine function looks like. So a normal sine function, or not like the parent function, looks like this. So to get one cycle, you need 5 key points. You want to make sure you have the x-intercepts, although if there's a shift, this could just be the equation of the axis intercepts, the max and the min value, which takes our period and divides it into sort of 4 key sections. 1, 2, 3, 4. So I'm going to divide my period into 4, and that's the scale I'm going to use. So for my scale, I'm always going to take the period and divide by 4. Or sometimes what's easier is taking the period and multiplying by the reciprocal of 4, which is 1 over 4. So in this case, that would be 2 pi by 3 times 1 over 4, which reduces to pi by 6. So I'm going to have a period of pi by 6. So that'll be pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, and 6 pi by 6, which is pi. 7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6, and 12 pi by 6, which is 2 pi. So remember, this one was pi by 6. And then I'm just going up by pi by 6's until I get to 2 pi or 12 pi by 6. Now, all I need to do is figure out my starting point. So where am I going to start my graph? So one thing that sometimes helps here is to graph your parent function. So I know my parent function for sine starts at 0, 0. The intercepts are at pi and 2 pi. The maximum value is 1, which happens at pi, or pi by 2. The minimum value of negative pi. So my parent function is going to look something like this. So now the transformed function, I'm going to think about this normal starting point for sine, the 0, 0. Where does 0, 0 go under these transformations? So 0, 0 is going to be affected by the shifts. So I had a phase shift of pi by 6 to the right, meaning 0, 0 is going to shift pi by 6 to the right. Okay, so whatever the phase shift is, that's going to move this point 0, 0 left to right. I also have a vertical shift. My equation of the axes was shifted up 1. So this y value of 0 is going to go up 1. So this is my new starting point. Pi by 6, 1. So right here. So that's the beginning of the period. Now I just want to graph one full period of this new function. So I know the period is 2 pi by 3. So 2 pi by 3 would be 4 pi by 6, or 4 of these little increments, 4 of these pi by 6 intervals. So 1, 2, 3, 4. So the distance between this point at pi by 6 and this point here is 2 pi by 3. And the reason is because I took the period, divided it by 4, so it's 4 of these little intervals. So 1, 2, 3, 4. So that's the beginning, that's the end. So thinking about a sine function, the beginning is here, the end is here. What happens directly in the middle? Well, it hits the equation of the axes again. So in between these 2 points, I'm going to hit the equation of the axes. What happens between the first 2 points where it hits the equation of the axes? Well, the sine function hits its maximum. So right in between here, it's going to hit its maximum, which we know is 3, 2 more than the amplitude, or 2 more than the equation of the axis. What will happen between these 2 points? It hits its minimum, which is down here. So this is one cycle of this transformed function. Now I just want to get the rest of the points, and to get the rest of the points you just basically are going to repeat. So I'm going to count every 4 sort of interval markers, or pi by 6s. I'm going to have the same y value. So 4 away from here would be at pi. Here is the equation of the axes. Here it's at the minimum, and here it's back at the equation of the axes. Here we're at our max again, equation of axes, and minimum. So I'll just complete that cycle. And I'm missing between 0 and pi by 6, but I know I must have a minimum just by counting sort of 4 interval markers over. So that is how you graph a sine function, and a cosine function will be very similar. The only difference for a cosine function will be your starting point. But that's how you graph a periodic function using transformations. Notice you're not doing it quite the same way you did the other types of functions.